Hi everyone, in this video I'm looking at chapter 11, Trigo Identities and Equation, and we look at the skill of how do we prove Trigo identities. So for this skill, very importantly, you must know on your AMath formula sheet, this section over here, you must know identities. We have one whole bunch of formulas and identities over here. You need to be able to know when do I use these different identities in order to prove your Trigo identities. Okay, there are all different kinds of identities which you should have learned. So now you need to know which one should I choose to apply. So before we go into that, there is no one right step because the time that you take to prove each identity really depends on the identity itself. I can only give you some tips on how you can help yourself do it faster. Okay, so first tip is try to identify the more complicated side and start from there. Either the left side or right side, always start from one side. You try to think of which one seems more complicated because it's always easier to simplify something complicated than to make something very simple to become very complicated. Okay? Then also next thing is that please note your presentation. If you first line start and say that left hand side is equal to right hand side as your first line in the working, this is already wrong because the question asks you to prove. For example, the question here say prove sine 2x is equal to this. Okay, if I start my working like this, okay, I start my first line, I write the left side is equal to the right side. Then I start to simplify my right side. And I simplify all the way to get to the answer here. This presentation is not accepted. Why? Because when the question says prove this, when you start by saying this first line over here, you're already saying that it is proven already, that these two are equal already. So it doesn't make sense to do anything else. Okay? So the right way to present this should be, instead of starting the first line like this, left side is equal to right side already, choose one side first. As what I mentioned, start with the more complicated side because it's easier to simplify. If I were to look at this identity over here, I think for myself, I would think the right side is more complicated, therefore easier to simplify, but it's really dependent on yourself. So over here, if I choose to start at the right hand side, alright, RHS equals to, in this case, tangent x, bracket 1 plus cosine 2x. Then from here, I continue to simplify from here, following the steps you see over here, all the way until I get my answer here, which is equals to sine 2x. Then from here, I can say that therefore this is equal to the left hand side, and therefore I've proven what the question wants me to show. Okay, so please take note of the presentation. Very important when you write proving questions. You cannot start from a line like this. Start from one side and state very clearly which side are you starting from, and therefore you can get to the other side. Alright, okay, I'll do just one simple work example so that you can think through also how do we simplify and get the result that you are required to show. Okay, let's look at one of this identity here. Prove the identity sine power 4x minus cosine power 4x plus 3 equals to 3 minus cosine 2x. So let's look at this identity over here. Which side looks more complicated? To me, the left side looks more complicated because I have a power 4 here. If I have a power 4, it is easier to simplify a power 4, a big power, all the way down to something simpler than to make this something complicated. Okay, so first I start with left hand side. LHS equals to cosine power 4x minus cosine power 4x plus 3. Okay, then from here, I see, what can I do? This one I have something power 4 minus something power 4. This 3 cannot do anything, right? So
I don't understand.
If you think about what you have done, okay, if you think about what identities we have learned before, there is no identity in the formula sheet that you can use to apply this, but what you can do is that you can recall what you have learned in lower sec, which is an identity which is useful, a square minus b square. This do something similar to that. So what I can do is that I can simplify this. So over here, I rewrite this in the power of something square minus something square. So I'll get, let's say, sine power 2x. Okay. Then square minus cosine square x. The whole thing is square. Okay. And therefore, this is of this form here. I know that this is equal to a plus b times a minus b. Okay. Therefore, I can simplify this to become sine square x plus cosine square x times sine square x minus cosine square x, then plus 3. Okay, then now if you recall your identity here, oops. Okay, this sine square x plus cosine square x, this is equal to 1. Okay, then I'm left with the remaining here. Sine square x minus cosine square x. Then plus 3. Okay, so over here, if I were to expand and remove the brackets, I'll get sine square x minus cosine square x plus 3. Okay, then from here I can continue to simplify. I see if I compare to what I want to get, 3 is over here already. I just need to turn this into cosine 2x. Okay, so over here let's rewrite the equation. I put the 3 in front. Then I want to have a minus sign. So I'll factorize out a negative from these two terms. Okay, this will become minus away cosine square x minus sine square x. Then if you check your identity list, you'll realize that cosine square x minus sine square x is actually cosine 2x. Minus cosine 2x. And therefore, this is equal to the right hand side. And done, we have proven this identity. Okay? So this is just one example. Of course, it is impossible for me to cover every single possible identity. So you just need to think about logically, with what you are given, what can you apply? If you apply your identities correctly, you should be able to simplify eventually towards the same final answer. Okay, but you must think strategically, which ones can I use from your formula sheet? Alright, so I hope this helps you to better understand how we can do proving, and I hope that you are able to prove more identities in the future. Okay, and that's the end of this video.